dealing hand cream in here now? Is that what the kids are all doing?
Champagne.
Champagne. I'm gonna pretend that champagne isn't like the flavor of hand cream, but it's actually like what kids are calling it. Some champagne, get some champagne.
Oh yeah.
It's a hot new drug. Champagne. Ugh.
No, that's terrible.
Oh, Macy, I identify with that sound. All right. Okay, first off, let's talk about vectors, because that's the easy part. It's just you forgot about it, yeah.
Can you drink, please?
It's me.
Thank you.
Weren't thirsty 5 minutes ago, but you're thirsty now, huh? Got it. That makes sense. All right, so I'm going to choose 4 of these to graph. The rest are on your own. I'm going to choose the first 4, okay? Again, this is not for a grade. It's a review packet, so you're going to be fine. Rip. Yeah, so am I. I stayed up until 2 a.m. making this stuff because I protested for 6 hours like, I don't want to do this. So I didn't. And then I finally did. All right. And that's how you adult. So we're going to graph these vectors. Remember, vectors can be placed anywhere. Vectors are not location. They are movement. So we pick a point to graph it. I'm going to pick this point right here. And then vector v is 3, -6. So that means 3 in the horizontal direction. That's to the right. You're right. And then 6 down, right? So pick a point and do that to it. We're going 3 to the right and 6 down. 1, 2, 3, 4, 5, and 6. So this is vector v. Label it as such. When you label it, you want a harpoon and a v.
So,
The harpoon is an arrow with half the arrowhead missing, right?
where did you get the first dot?
I made up my own dot.
Can I put it in the center?
Good for you.
No, can I?
Yes, you
Put it in a
can.
different spot?
Yeah, you can put it in a different spot. Remember, vectors are movement. They aren't location, right? So vectors can apply to any dot. You can just copy and paste that wherever you want.
So how do you get the line?
That's it? Awesome. That's so
Not kidding. I am kidding.
How do you get the line?
So I started with a dot,
Yeah.
and then I did 3 to the right and 6 down because that's what the vectors say to do,
Okay.
and that's the line. Remember, vectors are not dots. They're not coordinates. They are movement. So this is an example of a movement, 3 to the right and 6 down. Play it, sit wherever you want. Vector u is 2, -1, which means 2 to the right and 1 down. So I'm going to put it here. 2 to the right and 1 down means that we move like this. Vector u, again, harpoon with a u. There's another way to notate vectors. You give them little like hats, which is adorable. But like I think these help you remember what they are. So we don't use the hats. But you will in calculus probably. All right. A. Vector A is 8, 0. That means pick a point. Move it 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. And don't move any up and down, right? So there's vector A. Then we get vector B, which is pick a point. I'll pick this one. And move 3 to the left because it's -3 and 0 up. How do we feel about graphing vectors? Pick a point, do it. Marissa, is your understanding of vectors as good as your hair? Awesome. That is A+ understanding. All right, so now we're going to find the magnitude, which is the length of these vectors. The way we do that is Pythag, right? Because we have a vector that's at a diagonal for v, right? So if we break it down into how far it goes up or down and how far it goes over, we can figure out how long the thing is. So we're going to do Pythag, which is a squared plus b squared equals c squared. We're going to use its components to do that. So up here, the magnitude of vector v, this is how you write magnitude. I do it with 2 lines on either side. You can do it with just 1 line on either side if you want. I do it with 2 because I think it looks dope. The magnitude is going to be a squared, so the horizontal component squared, so 3 squared, plus b squared, the vertical component, -6 squared. And then we're going to root it because that's going to give us the length, right? That's Pythagorean theorem, a squared plus b squared equals c squared. We root both sides to get c on its own. So now we do math. We get 9 plus 36, all rooted. That's going to be 45, yo, rooted. So that's the magnitude. Yay! If we were to do that with vector A, we'd get 8 squared plus 0 squared. What's 8 squared? 64. What's 0 squared? 0! So 64 plus 0 is 64. Then we root it, we can get 8. Which makes sense because you can count it. It is 8, isn't it? It's 8. It's 8. Landry says this checks out. And she's got a headache. Very trustworthy. Questions, comments, concerns other than for my mental well-being? Yes.
So, there's going to be one like this in the test.
Wait, what
And
did
so
you
we
say?
have to
Can I see the
do
graph?
that for
Wait.
every one of them.
Yes.
I think I did that one.
Which you like because while it is time-consuming, it gets you lots of points. Yes, sir. Absolutely. Again, you can pick any point you want, Calvin. The idea is, can you apply the vector? If it's 3 to the right and 6 down, then make it 3 to the right and 6 down. Pick any point you want. Yeah.
How many points will it be worth?
1 million. Everything's made up and the points don't matter. Yes. Put it back when you're done. 2? There is no planet B.
Oh, yeah, she needed
That's the sound of our planet just like being blown out your nose. All right, you're going to find the magnitude for all those. I'm not going to do any more because who cares? Diana, no crying.
I'm not crying.
Okay.
I'm just looking.
Negative 1 squared.
Because I can't see, okay?
Yeah, because it's -1 times -1, which is a positive number. Yep. Flip the page. All right, now, next page. It says translate each preimage by the given vector. We're not talking about como se dice, okay? Translate each image. It means that we're going to slide it, right? We're sliding. So preimage means what we're starting with. Image is what we end up with. I prefer to use the terms preimage and postimage, right? Before and after. Would I be a before or an after? What do you think? After, that's right. Okay, so write the rule and then write the prime coordinates. Okay, you've never seen this format before because we've never done homework on this because I was like, who cares, right? But hopefully the homework, the format doesn't scare you. If you have questions about what this all means, I can help you with that, okay? Again, it's just setting you up for fill in the blank, which we like. Okay? So here's what we're going to do. We're going to translate this triangle by this vector, 6, -2. That means 6 to the right and 2 down, right? So take A, for instance, and go 6 to the right. 1, 2, 3, 4, 5, 6, and 2 down. And that's where A prime is going to end up. We use this vector to get from there to there. We split it, right? We're going to do that to all our points. So we're going to go 6 to the right and 2 down for every vertex. Take C, for example. 6 to the right is this. 1, 2, 3, 4, okay, 6. And then 2 down. So there's C prime. And there's the vector that did it. Oh, that was a good one. B, 6 to the right. 1, 2, 3, 4, 5, 6, and 2 down. So B prime is going to end up here. There we go. That's another good one. And then when we're done, we connect the dots. So we move the entire image. Boop. 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 Aw, man. The first one was so good. I got greedy. How do you feel about that?
Pretty good. Like the new coordinates.
Yeah, there's a couple ways we can do it, right?
Oh. Okay.
So slide it. Yeah, it's going to overlap a little bit. Isn't that annoying? I know, I do it on purpose. Oh, yeah, I made the quiz last night, too. Yeah, the quiz tomorrow is going to frustrate you. It's ugly.
So exciting.
No, I know, right? Frustration. Don't get frustrated. All right. So, what is the rule then? Well, what do we do with all these coordinates? Well, the x value and y value is what we started with. And then we added 6 to whatever the x was, and we subtracted 2 from whatever the y was, right? Isn't that basically what we did? That's the rule. You add 6 to your x and -2 to your y, and that gets you to the new coordinate. Because we moved it 6 to the right and 2 down. So we can either copy down these coordinates and put them here, or you can do your rule, or you can do both and check your work, right? So the rule is add 6 to the x and -2 to the y. So if I start out at -6, which we do, I made sure it was correct. Last year I actually goofed up the coordinate there. -6 plus 6 is 0. And 6 minus 2 is? Look, and 0, 4 is where it is. Oh my God!
Oh my gosh.
That's right. We are all children of God here. Do you think he cares?
No. I mean, yes. Not heavily.
All right. B to B prime. The question is, what does he care about? So, negative 8 plus 6. And does he care what we care about? 1 minus 2.
You should bring back the dinosaurs.
I know. When I went to my friend's house growing up, every time they'd end their prayer, they'd say, and thank you for the dinosaurs. And I thought that was great. Bunch of nerds. All right. Negative 1 plus 6, 5. 0 minus 2 minus 2. And look, that is. Wow. Good gosh. Heckin' yeah. Yeah.
So, like, you could just, if you, could you just look at it on the graph?
Yeah, you could.
Just fill that in?
Yeah, they should match, right?
Yeah.
Heck yes. Heck yes. I'm going to leave number 3 for you. Have fun. Ready to turn the page? Yay, translations! All right, so now they give you the before and after, right? And they want you to figure out what was the vector that did it. We go towards prime, right? Prime means new. So from B to B prime, that's our vector. From D to D prime, that's our vector. From C to C prime, that's our vector. And A to A prime, that's our vector. And look, they're all the same vector. Of course they are, because it's a slide. Everything gets moved the same, right?
Of course.
So the question is, what is that vector? Meaning, what are its components? Pointy brackets. We're not talking coordinates here. We're talking vectors. You don't need to do this, but I'm going to do it so you can see where I'm getting these numbers from. If I start on B and go towards B prime, which I am, right? We go towards prime. I had left 3. Again, direction matters here. And then I go up 10. So what's our components? Well, negative 3 in the x direction and up 10 in the y direction. So that's the vector we used. And if you notice, that's the same vector for all of these. Because it's a translation, right? So you only have to write it once. I know! That's it. Now we got to find the magnitude. Good job reading. All right. So, trying to encourage that here. Raise reading scores. That's what it's all about. All right. So we're going to use Pythag to solve this one, right? So we're going to take negative 3 and we're going to square it. And we're going to take 10 and we're going to square it. And then we're going to root them. Right? So, negative 3 squared is 9, and 10 squared is 100, and it's still under the root, so we get root 109, which is slightly more than 10, right? Because root 100 would be 10. So root 109 is 10 and change. That's how long that vector is.
Someone's trying to out-music you.
We should play Christmas.
A Mac imposter.
I heard elephants earlier.
Who's playing?
I don't know.
That's what I was wondering.
I'm really glad I didn't do what I was thinking of doing, just to go out there and just sing really loudly, and then right as we walk by, it was right in your ear. Yeah, it would not have been good. Trying to make friends. All right. Questions on that? Bueno. Dang, yeah, it looks even better from the side. All right. She does. Marissa, hair MVP.
Thank you.
Bailey, you might be other MVP, though. I can't decide.
For what?
For hair.
Hair.
Yeah. Jenna also has great. So many of you have great hair. All right. Forget what I said. Mark wins. All right. 6. When I woke up this morning, I had this sudden urge to be like, during 4th hour, I just need to go Mark, 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 and get everybody involved. But like, that's dumb. So I'm not going to do that. Yeah. You do now. Sorry, I'm just seeing the business. I'm not getting the party in it. Oh, there it is. Woo! All right. Heck yeah. We're all children of God. All right, so we need to graph this line. We're going to do reflections. Are you ready? Let's read the instructions. Reflect each point over the given line of reflection. So that's what we're doing. That's the idea, okay? Plot the point first. You can do that. So don't leave this blank. Plot the frickin' point. Frickin'. That's acceptable. The heckin', okay? And then graph your line of reflection. Here's your line. Here's your point. I'm going to graph the line of reflection. Here I go. What's my y-intercept? It's 4. 1, 2, 3, 4. Then I'm going to use my slope. My slope is down 1 over 1. And I'm going to do that a bunch of times so I can make a very accurate line. What's your question?
For, you know how like for slope, since it's -1, could it be like, could you do up 1 and
Yeah.
make
So
it-
check it out.
Oh, yeah.
This is the same as this, right?
Yeah.
And that's why. Good job. Yes.
Is that also the same as like -1/1? Like where it's 1/1, but the negative is in front of it?
Yeah, they're all the same, right? But they're not the same as this. Because that would be a positive answer. Right? That is not the same. One of these things does not like the other, and it's this guy. There's our line of reflection. Our point that we're going to flip. Stop using this pen, Mr. Mac. Oh my God, they're all low on ink. It's because I grade with green, and you guys get a lot wrong. All right, 1 -3 is A. I hit my peak in 6th hour yesterday, so you guys should all watch 6 hours video because it really clicked for people on reflection. So if you're struggling with that, normally I hit my peak in here. I'm back at it. All right. I would highly encourage you to watch 6 hours video. I really would. It really clicked for everybody. All right, so here we are. We're going to flip that point. So in order to flip it, we need to find the perpendicular line because reflections happen perpendicular to the mirror, right? So we're going to find that perpendicular. We know that perpendicular lines have perpendicular slope, and perpendicular slope means we flip it and change the sign. So our original slope is -1/1, right? If we flip it, it's still 1/1, and then we change the sign. So it's going to be positive. Positive 1. Now we don't know what B is, because right now all that represents is every possible perpendicular line I could draw, right? They all have perpendicular slopes, so they're all going to be perpendicular. The question is, where do they hit the y-axis? Well, we want the one that goes through point A, and it looks like it's going to hit it at -4, right? Looks like that. But let's find out for sure. The way we do that is we say, look, I want it to be perpendicular, and I want it to go through this point. So we plug in that point to see what B has to be. Okay? So I plug in 1 for x, because that's the x value. And I plug in -3 for y. Are you with me? Wonderful. I got a head nod from Ellie. Shout out to Ellie.
Shout out to you, girl.
So now I'm here. I subtract 1, I get b is -4. Oh my God, I was right. I'm sorry. Oh my gosh. I'm gonna be honest with you. I don't think he cares about that. But like, that's just me. Okay. Y equals x minus 4. That's the perpendicular line. So -4 is the y-intercept. Up 1/1 is the slope. I don't need to graph it. And I specifically put that in the directions. That way if the line's really gross, you don't have to do it. But it is helpful. Because now I know that A is going to flip over onto here somewhere. And I can kind of eyeball where it's going to be. The reason you can eyeball it is because I gave you nice numbers. Because I'd like them to be nice. That way you can show me you know the concept. So don't just eyeball it. Take advantage of the nice numbers and do the actual math, okay? That way when the numbers do get weird, which they will, you'll be better, okay? Is everybody cool with what I did so far?
Of course.
Plot the original stuff, find your perpendicular line. We good? Now we need to figure out where they intersect. Well, we can eyeball that, but we're not going to, because again, the numbers are nice here, which is convenient. But what we're really going to do is do some math. How do I figure out where the lines intersect? I set them equal. This equals y, and that equals y. So they should equal each other. So I'm going to write -x plus 4, which is our original equation, right? And I'm going to set it equal to our perpendicular equation, x minus 4. I'll pause for station identification. We're setting our original stuff together. That's because you done goofed. Yep. Let me show you why. You added x over here, and you said it was 0x.
Oh, I didn't do negative.
Yep. I'm a frickin' psychic. All right. So I'm going to add this x over. You could have subtracted x and got -2x. I'm going to add it, and we get positive 2x. I'm going to add the 4 over, and I get 8. Is that cool? Then I divide by 2, and I find out that x is 4. So that means our midpoint, where they intersect, is at 4, comma something. The question is, how do I find the y value? Hannah?
Plug in the x.
Yeah, and I can plug it into either equation because they agree at 4, right? They intersect there. So they're going to have the same answer. If I plug it into the red equation, I get 4 minus 4, which is 0. If I plug it into the blue equation, this guy, right? I get negative 4 plus 4, which is 0, right? So they agree there. It's good that they agree. That means they intersect. If they don't agree, you done goofed. Stay with me. So that's the midpoint. How do you feel about finding that? Set them equal, do the thing, okay? Now, our last step is to use that midpoint and A to flip A prime to its reflection, right? Or A to A prime, right? So we need midpoint formula. What is midpoint formula?
Average of x's and the average of y.
It's my girl. Yeah, you had it.
I did.
You had it. I believe you. When we average stuff. Ellie!
What?
Do we add or subtract when we average stuff?
Add.
That's right. How many pieces do we have when we're adding for midpoint? How many things are we adding when we add for midpoint? 2, right? So we're going to divide by the number of pieces. That's averaging, right? Add them up and divide by the number of pieces. That's midpoint formula. It's not subtraction. We're not doing distance. We're finding the average point, the midpoint, right? So we know the midpoint. The middle is 4, 0. And we know one of our endpoints. It's 1, negative 3. We're going to look for the other endpoint. So our midpoint is 4, 0. So M is 4, 0. And that's going to equal this. Again, these are coordinates, right? Both these are coordinates. This is the x part, and this is the y part. The x part is going to be the average of our x's, and the y part is going to be the average of our y's. We know one of our x's and one of our y's. It's the original point that they gave us, 1 and negative 3. Where did I get those numbers from? You're going to ask. I got them from here. From here. That's our endpoint. That's our midpoint. We're looking for the other endpoint. The other endpoint's going to be these guys. We're going to do this math in our heads. You can do it on paper if you want, but I think we can do this together in our heads. I know these two things equal each other, right? They're yawning in math class.
Sorry.
How do I get rid of the divides by 2?
Multiply 2.
When I multiply by 2, the 4 becomes a 8. Very good. So now I'm here. I've got 8 equals x plus 1. How do I get rid of the plus 1?
Minus 1.
Good. So 8 minus 1 is 7. I'll do it again. I multiplied by 2 to get 8, and I subtracted the 1 to get 7. Multiply by 2, subtract 1, 7. Same thing here. It's actually a little bit easier because when we multiply by 2, what do we get?
0.
Still 0, right? These two go together, right? So I'm at 0. How do I get rid of a plus minus 3? In other words, how do I get rid of a minus 3? I add 3, right? Yeah, plus negative 3 is just minus 3, right? So I add 3. I'm at 0. I add 3, I get 3. Double it, it stays 0. Add 3, I get 3. How do you feel? Did I lose people there?
Yeah.
Okay. This part right here equals this. So I get rid of the divides by 2 to get x on its own, right? I times by 2 to do that. I get 8 over here now, right? Got 8 in your head? Okay, so the divides by 2 is gone. And how do I get rid of the plus 1? Subtract it. So 8 minus 1 is 7. Better? Same thing here. I double it, it stays 0. I add 3, it's 3. Okay? So that's A prime. Let's go plot it and we're done. 7 comma 3. You're yawning in math class. 1, 2, 3, 4, 5, 6, 7, up 3. There she is. She's beautiful. All right. Let's break it down. Here's what we did. We graphed the original line and the original point. How do you feel about graphing the original line and the original point? You feel great. Then we find the perpendicular line. How do you feel about finding the perpendicular line? Flip and change the slope. Find B by plugging in your point, right? Then we set them equal to find where they intersected. We did it. They intersected 4. We plugged it back in. Got 0. Then we take the intersection and plug it into midpoint formula. Average of the x's, average of the y's. There's midpoint. There's our one endpoint. We're looking for the other one. There she is. Again, original line and original point. Then we found the perpendicular line. Then we found where they intersected. Then we found A prime by using midpoint. What is the midpoint formula? What is it, Ellie? At least one person knows it. All right. Would you like to try number 7, which is easier, or would you rather skip to number 8? Okay. We're going to hit number 7 on the way back because there's one other thing I want to show you there. Number 10, good God. If you can get that one, you're a master. 10 is a disaster.
Number 7 doesn't
It's an easy level one. There's one thing about it that's slightly different than the first one we just did.
goes off the.
It does, doesn't it? So you have to be clever about how to graph that. Use your slope and a point that you know is already on the line. I'm going to come back to it. Go to 8. All right, you're not writing anything. Nothing. Absolutely nothing. I do like your glasses. All right, we're going to graph this line. 4, 1, 2, 3, 4 is the y-intercept, and our slope is down 1 over 3. If you're not writing anything, your eye should be up here. Down 1 over 3. Again, I'm not going to call you out on it or be mad at you, I suppose. Just advice. I know you guys are struggling to focus. I'm trying to help. This is our line of reflection. Take out Saddam. All right. Then I graph the original point, which is 1, negative 3, which is the same point we used last time, actually. Mr. Mack is lazy. All right, so now we're going to flip this thing. The way we do it is we know we need to find the perpendicular. So y equals, when I flip this slope, what do I get?
Positive 3.
3 over 1, and it's going to be positive because we changed the sign, right? 3 over 1 is 3. Now I'm going to take this point, and I'm going to plug it in here. 1 for x, and negative 3 for y. I do math, and I get that this is 3. I subtract 3, and I find out that b has to be negative 6, so that when we plug in 1, we get negative 3. So that point's on the line, right? So our equation is going to be y equals 3x minus 6. I don't have to graph that, but it's easy to graph, so let's do it. Down 1, 2, 3, 4, 5, 6 for the y-intercept, and then up 3 over 1. Look, it does go through A. I can keep doing that. I can see where it intersects. That's fine. I'm not going to draw any more than that. I know A prime is going to be somewhere over here. I bet you can eyeball it. It's going to be right there, right? But we're going to do the math because the numbers eventually won't be as nice. So let's get used to doing the math when the math is easy. So now I need to find out where they intersect. Again, I could eyeball it. Looks like 3, 3. It will be. But sometimes it won't be if the numbers aren't nice. So let's check. I'm going to take the original equation. And I'm going to set it equal to the perpendicular equation. All right, here's where it gets hairy. This is why this is a medium level problem, okay? So I'm going to add 6 to this side, and I'm going to get 10. I'm going to add a third x, right, to move this whole thing over, and I've got 3x already there. I need common denominators to add those together. Whoops. How many thirds are in the number 3? 3 thirds. 3 over 3 is 1. Oh, wait, we changed the problem, didn't we? 3 divided by 3 isn't 3. So there aren't 3 thirds in 3. How many thirds are there in 3? 9! Because 9 divided by 3 is 3. Maybe you don't like that. Isn't 3 just 3 over 1? Okay, how do I make a 3 on the bottom? What did I do to the 1 to make it a 3? Multiply by 3. We multiply top and bottom by 3 to make it kosher. Bottom becomes 3, top becomes 9. Cool. Commie denomies. So I've got 9 thirds x plus 1 third x. How many thirds of x do I have then? Whoops. 9 thirds x plus 1 third x. 10 thirds. 10 thirds of x. Here's how you think about this. That's 10 times x divided by 3. So we can either get rid of the 10 times x first, or we can get rid of the divides by 3 first. I always like get rid of division first. I think it makes a better world, right? Before we start messing with other stuff. So let's get rid of the divides by 3. How do we do that? Multiply by 3. So I get 30 equals 10x, right? Because that was 10 times x, and we got rid of the division. Cool. So now I divide by 10, and I get 3. Yay! No yawning in math class! So our midpoint is going to be 3 comma something. Right? We found the x part. Now let's find the y part. Where do you want to plug it into? This one or this one? Blue or red? Red, red, red. What's 3 times 3? Minus 6? Aw, what a coincidence. 3, 3. And it is. That's cool. So now we're going to take that. We're going to do our last thing. We're going to use midpoint formula, right? We're going to plug in our midpoint. We're going to plug in our original point. We're going to find the reflection. So here we go. Midpoint formula is what? Very good. When we average, we add. We know one of our x and y's. It's our original point. 1, negative 3. Now we do math. Let's do it in our heads. Times 2 I get. Subtract 1. 5. So a prime is going to be 5 comma. Times 2 I get. Add 3 I get. 5, 9. That's my height. 1, 2, 3, 4, 5. Up 9. There she is. Over 5 up 9. There's a prime. There's the reflection. How do you feel? Better? Here's what we did. Graph the stuff. Find the perpendicular. Find where they intersect. Do midpoint. Yes.
Can I write that down?
Sure.
Wow.
It's going to have to get tiny.
I'm blind, so I can't see.
You can also go back and watch the video and like and subscribe and leave a comment.
I don't have time for it.
Ring that bell.
I am too, but I don't watch them.
It would. I can't make you do this, but it would be really nice if before you came in to see me for help, you watched the video first, because odds are I'm going to do exactly the same
I
thing.
watched it when I was sick.
Good for you. How you like them apples? How you feel?
I really like the Honey Crisp apples.
Honey Crisp is all right. Pink ladies are the best. That is a fact. Pink ladies. You ever had pink lady apple? It's the best. They are the best.
I'll eat one from the
Facts, no printer, as the kids say.
Do we need a sheet of card paper?
No.
I'm the world's slowest note taker also.
Yep, which is why you just shouldn't, because like you're not gonna look at them anyway. Let's be honest.
Yeah, I do.
Really?
Yes.
Nerd.
For when I fail the test and then I have to redo it.
You could just like watch the video.
But I don't want to.
Got it.
It's easier for me to just read. I can't.
Bailey, how about I just give you this when I'm done?
That would work.
Ellie, would you like this when I'm done?
Yeah.
Okay. Well, now we have a fight.
Can't you just print another copy?
I could just give it to my favorite, I suppose.
Yeah, that's pretty good.
Oh, Bailey's
Yep.
a good
Natalie
noodle,
gets it.
so.
Yeah, I'm a good noodle, so.
Winner's a good
Let's be honest, I
noodle.
give it to Mark. 10 out of
With the
10.
good hair.
Becky with the good hair.
Isn't it Becky with the bad hair?
Not when we're talking about Mark.
Okay.
He's tall and he has good hair. That's all he's got going for him. But he is both of those things.
Are we doing number 10?
No, good God, no. Let's not.
We're not?
Number 10 is super duper crazy hard
Okay.
because it's really awful fractions.
If
If I do it, can I?
Yes!
Self-development?
Yeah! I love how you said self-development, not extra credit, because I don't do that crap. That poop. That garbage. That heck.
I'm mad.
Oh yeah, self-development.
Yeah.
I need some of that.
There's two scenarios. Either A, I don't get you the, like, in time how much you have before the final, right? And then it doesn't matter, and it'll be fine for everybody. Or option B, I do get it to you in time, and then it will matter, right? But either way, you'll be fine, right? That's the scenario. Again, always one thing falls on the back burner. It's always self-development. I try so hard, but in the end, it doesn't even matter. Bailey, did you feel that in your soul?
We get
Bailey, you're edgy just like me.
I am.
We get self-taught points whenever we come in, right?
Yeah.
Don't we get 2?
Yep.
I'm official.
And you need 10.
Yeah.
Is it because of me?
No,
Is it your family? Is it because of your glasses or your dog?
neither.
Okay. Is it your sister?
Because of
Of
Jenna.
course, no, it's not.
Okay. So all you gotta say is one word. Boom! Elbow to the temple. She'll never see it coming.
Oh my god, yesterday I scared the crap out of her. I was hiding, our fridge is like the only thing we have in our kitchen, so it's like right by the door.
Okay.
I opened the fridge door, I hid behind the door, Molly walked inside the house, and I jumped out, and she was in a really bad mood, and she was so mad at me. I was scared for my life.
Yikes. So you scared her, but she scared you more. Got it. All right, number 9. Actually, no, I said we go back to number 7, right? Let's do number 7 really quickly so you can learn how to graph something when it isn't playing nicely. 7. Okay. So I'm going to stop halfway through this because the rest I think is pretty much the same as we've done before. I'm going to graph the original equation, y-intercept at -3, up 1 over 1 for our slope, right? Saddam, where did you go? Here you are. There's our line of reflection. Our point is at -2 down 11. That's here, number 7. Here's A. I graphed the line of reflection. I graphed A. Now I'm going to find the perpendicular. Don't write this. You don't need to. Who cares? No one cares. Our slope is 1, right? So we flip it. We still have 1. Then we change the sign. We get -1. So -x plus b. We plug in our point. Our point is -2, -11. So -11 goes for y. And -2 goes for x. When I plug that in, I wrap it in parentheses. If you don't, you're going to miss the double negative. When you plug it in, wrap it in parentheses. It prevents a lot of little mistakes that you might make that I have to teach later, fix later. So we get -11 equals +2 plus b, which means -13 is b, which means the equation is -x plus, I'm sorry, not plus, -13. And just like Bailey said, oh no, how do we graph that? First of all, you don't have to. Second of all, if you do want to, -13 don't fit. What's your question, Ellie?
How is x negative? Okay.
Flip and negate. Yep, it's cool, it's cool. So -13 is going to be off the chart, right? Well, we know our slope is -1, right? And we know that A is on our line. So why don't we just use our slope from that point instead of using it from the y-intercept? Ta-da! That's how you graph it. I'm going to say that again. Instead of going all the way down to -13, which would be here, right? Use a point you already know that's on the line, and use your slope, down 1 over 1. Done. You can always use a point that you know is on the line, right? You don't have to use the y-intercept. Y-intercept's just convenient because it gives you a free point. But we already have a free point. So use your slope from there. And there's the line-ish. I missed. Whenever I say I miss, I think of my sister Kayla, who was trying to teach us how to play soccer. She was 4 and I was older. I don't know. Kayla's always 4. I can't remember how old she is. She's going to be a doctor. She's got to be older than 4, at least 5. And she was teaching us how to play soccer, and she had the soccer ball in front of her, and she's like, and then you go like this, and she ran towards it and fell over onto the ball, and she says, oops, I missed, and then got back up. It was adorable. Yeah.
When I was at the doctor's office, there's a little girl was running, and she slipped on a crayon, and I started laughing. And
That's me.
the dad looked at me and gave me the dirtiest look.
Me and my grandmother. My sister tries to ride a bike. She falls over. We both laugh. She's crying. There's blood. Traumatic experience for her. Hilarious experience for us. So
One of my neighbors, when I lived in my 7th
sucks to suck.
one of my neighbors, he was riding his bike, and that road is filled with potholes. He fell off his bike and broke his wrist. I didn't laugh. I laughed in my head though, because he fell.
Yeah.
But I walked into his house with his bike, and I told his grandpa, and yeah, he got a cast.
Hero.
Yeah, I am.
I have a heroic bike story that I can tell you sometime, but I'm not going to tell you now.
I was racing my sister on a bike, and I stopped to look both ways, and she didn't. And she almost got hit by a car, and I got in trouble.
Classic older sibling, right? Yeah.
One time, my brother tripped over my bike and hit his head on the hammer, the back of the hammer. He had to get his forehead glued
Wow.
shut, and he's went down.
Your siblings are all morons.
Yeah.
I injured my siblings a lot.
My sister ran into a cat tree.
I pushed Emery into a radiator.
That's right.
She had to get her
One
head.
time I rode my bike into a parked car and I bruised my rib.
And I also ripped an ice cube off her tongue. Really nice. And
Is this confession? What are we doing here? All right. Questions on this? How do you feel? How do you feel about 6 and 7? Do you feel like you could do those?
I don't know. I got 0 for X, but I don't know if that's right.
Watch period 6's video from the other day. For 7,
Yeah.
are you talking about the reflection point or the midpoint?
The X.
For which coordinate? The midpoint or the reflection? Midpoint or A prime? Because neither, actually.
It's neither.
It's neither. Well, look at it. Here's our line. A prime is going to be somewhere around here, right? And the midpoint's there. Neither should be 0.
Obviously not.
It's not going to be 0. Yep. But hey, that's good. You can think about it. You might not got to write the answer, but you learned how to think about it. How can I help? Any other way I can help? Okay. Yes, 25. So here's scenario A. Scenario A is I actually get you that information before the semester ends, and then you'll know and you'll have time to actually do something about it. And we're running out of time, so my time is running out to get you that, right? And if I don't get you that, scenario B, then you're fine. So you win either way. Something you shouldn't worry about is something I need to worry about. Something always ends up in the back burner when I implement my system in a new school, and inevitably
Don't have enough self-development.
it's self-development. Everything's made up and the points don't matter. I do what I want. A wave of my hand and self-development doesn't matter for a semester. All of you have pretty much got it, because all of you have been in here for help. At least 5 times.
I haven't.
Chance once. Okay? So, you're going to be fine. Everybody's done stuff when the sub was here, right?
No.
Yeah, exactly. That's a problem. But it's going to be 20 points next semester, so I'll get you then.
I looked at it and I gave up.
I turned it in.
So,
The whole point of self-development is to not give up and to try. It doesn't have to be right. But see, you are a person that has to be right and has to have the right answer. You can't just mess with stuff and learn, which is going to be a problem because guess what? Learning isn't about getting the right answer, but school is, which is why school work for you, but learning do not.
Which is why
That's
school
why we should
is
just ban school.
dumb. Yeah.
Who taught the first teacher?
who what?
Who taught the first
Diana's asking the real questions, right? Wow. But then who taught that teacher?
Who taught the first teacher? He decided that he wanted
He?
How do you know she?
Boo!
Who taught the first teacher?
Someone thought about learning and how to learn. And they became the first learner of learning. And that's when the first teacher was born. Is the answer Jesus?
I'll be the last learner in my bloodline.
Wow. I love how you say in my bloodline. Anything with that ends in my bloodline as a sentence is instantly cooler. I will enjoy this meal more than anyone else in my bloodline. That's dope. Oh man, that wasn't live? I guess I'll have to upload the video later.